Okay, in question 4 part A, they give us f of x and ask us to find f dash of x. Don't be put off, this is as easy as it looks. This is core 1, easy peasy differentiation. And the reason why they've asked you to do that is because in a.e2, where you're integrating a fraction, oh look, here's the f of x we had appearing on the bottom of the fraction, and the top of the fraction won't be a million miles away from the answer you got to A part 1, so you can recognise this as an integral where the top is more or less the derivative of the bottom, and in your chapter 6, sort of a few pages in, you'll find the method you need, a standard kind of integration method. On part B, we've got to use a substitution, u equals 2x plus 1, so this is the last method in chapter 6. Look in there for your worked examples to show that this becomes this integral. What that means is that dotted 2 is going to be a re-entry point. Even if you can't get these 3 marks, you can assume that answer and follow it through to get this part here. But coming back to here, you need to follow the method for integration by substitution. You need to start with, on the right hand side of the page, u equals 2x plus 1 du by dx. First thing you always do with your substitution is differentiate it and decide how you're going to replace that dx there in terms of du's. Now it's fairly obvious how the 2x plus 1 is going to turn into a u inside the square root. This x here, sometimes those x's cancel. I don't think this one will be cancelled out by what you're doing with dx, so you're going to need over here to make x the subject of your substitution and put that in terms of u in order to get here. But as I say, you've got examples of this in chapter 6. This is about the third example on integration by substitution where the x doesn't cancel out for you. And then even if you can't get that answer fully all the way, you can assume this is correct, perform this integration, get the answer out in terms of u, and then you're going to need to convert that back to x's in order to put the limits in, or if you prefer, you can update the limits so they apply to u instead of x and put them into your UE flavoured answer that you got from part B1. It's show that, so we need to end up with 19.9 to 3 significant figures, but to be convincing, what you need to do is get more accuracy than the first decimal place and then round off to 19.9 so the examiner is convinced you've got a precise answer and you really know what you're doing.